most vivid images to have emerged from Operation Desert Storm were these scenes of precision-guided bombs. Time after time, with pinpoint accuracy, these weapons flew into their targets. Come with us as we examine the secrets behind the guided bomb. The ability to deliver a weapon against a target with 100% accuracy has been a quest as old as warfare itself. The first serious efforts to develop guided weapons for aircraft took place in World War II. Until then, the most precise strike aircraft were dive bombers and other light attack bombers, which struck from low altitudes. But their bomb load was small, their range was short, and they were vulnerable to enemy fire. The long-range heavy bombers of the day attacked from high altitude. This was done to lessen the threat posed by the flak from enemy anti-aircraft gunners. But high altitude meant low accuracy. In 1941, the British Royal Air Force discovered that only one bomber in 10 was able to put its bombs within 5 miles of the intended target. Improvements in navigation, training, and bomb sights helped improve accuracy. But high-altitude bombers in World War II were only good for area bombardment, saturating a target with hundreds of bombs so that a few would hit. It typically took several hundred bombers to destroy a single target, and precise maneuvering targets, such as warships, were an even more difficult problem.
Throughout the history of air warfare, there's always been a trade-off between the accuracy of bombing and the losses that the bombers had to suffer to achieve that accuracy. And so you had to have very brave crews who were prepared to go right into the target to drop the bombs accurately if you were going to do it. Now, the Germans had another problem. They were not a naval power, but they were fighting a naval power, that's to say Great Britain and, of course, later the USA. So what they really wanted to do, they wanted a system that could attack ships, moving ships in open water. And if you take a battleship going at maximum speed, he can cover about 400 yards in the time a bomb takes to come from high level. Why drop the bomb from high level? Because if you don't, it won't have enough velocity to penetrate the deck armor of the battleship. So, for those reasons, the Germans developed 2 types of anti-shipping weapon, the Fritz X and the Henschel 293, 2 specific types of anti-shipping weapon.
The Germans were the first to develop successful guided bombs. Their story has been largely forgotten. Guided bombs were hidden under a veil of secrecy. Even after their existence was declassified, they were overshadowed by the more dramatic B-1 and B-2 vengeance weapons. Both guided bombs, the Henschel 293 and the Fritz X, were developed by the same team of German engineers, but for slightly different missions.
The Fritz X was really just a bomb with a radio guidance system, just an ordinary armor-piercing bomb. And this thing, it was unpowered, it was released from about 20,000 feet, and during its descent, it built up to a velocity pretty close to the speed of sound. And there was a case of one of them hit the British battleship, HMS Warspite. It penetrated through 6 decks and blew out a hole in the bottom. The ship was out of action for a year. So this is a very powerful armor-piercing weapon. The Henschel 293 was a quite different weapon. This was for use against unarmored ships, and it was for use against merchant ships. And this was like a little glider, 10-foot wingspan, and this was released from a much lower altitude. It had a little rocket booster on the back to boost the speed up to about 370 miles an hour, and then it coasted down as a glider until it impacted. The guidance was the system, what we would now call command to line of sight.
Command to line of sight guidance used a radio control system essentially similar to today's radio-controlled model airplanes. The operator used a joystick controller which activated the control surfaces of the guided bomb by means of a radio signal.
There was a flare in the back of the missile, and the operator inside the aircraft had a little joystick controller, and he would steer the missile to fly down the line of sight. And what he did in effect, he superimposed the flare apparently on the target and held it there until the weapon impacted. That was how these things worked.
The missile control joystick was operated by the bombardier sitting in the nose of the aircraft. When the joystick was turned, radio signals were transmitted to the guided bomb. The radio transmissions were translated into control commands to steer the missile. When first used in combat in the Mediterranean in 1943, their results were startling.
Well, they came in with a bang, literally, because the first mission, one of the very first missions that the Fritz X was employed on, that was when the Italian battle fleet was surrendering and it was sailing out to Malta, and these German Dornier bombers caught the fleet and they sank the Italian battleship, the Roma. They got 3 hits on her, started an ammunition fire, and she blew up. Another big Italian modern battleship, the Italia, was seriously damaged. So this suddenly got everybody's attention. This was rather like the later sinking of the Israeli destroyer, the Eilat. Suddenly everybody focused on, good heavens, here's a new and important weapon and we've got to learn how to deal with it.
After the initial successes of the German guided bombs, the Allies attempted to develop new technologies to render them ineffective. The US Navy tried to use electronic means to jam the guidance signal between the bomber and the missile. But the downfall of these new weapons came from other directions.
It was a first-generation system, and you will have problems with the reliability of any first-generation systems. Crews had to be trained up ab initio to use a thing like this. But the biggest problem of all that they had, after some initial successes, the British and the American navies wouldn't put their warships where they were likely to come within range of these units. If they did, they had very good fighter cover. Now, with any sort of air-launched weapon, it's no more effective than the ability of the bomber to get into an attacking position and get it to the target. And this was the problem the Germans found. If these aircraft came under fighter attack, because it was a command-to-line-of-sight system, if the bomber had to peel away to avoid a fighter attack, it had to abandon the missile, which missed the target.
Like Germany, the United States was fascinated by the potential of guided bombs. The first American guided bomb to be used in combat was the Air Force's Azov. This was a radio command bomb, but simpler and less versatile than the Fritz X. It was used to attack vital rail junctions, bridges, and railroad tunnels. For larger targets, the GB-1 glide bomb was developed. It could be released several miles from its objective so that the bombers could avoid the dense concentrations of flak around the targets. First used during a raid on Cologne in May 1944, the early inertial guidance system proved ineffective. The bombs often got caught up in the strong slipstreams of the bomber formation, which ruined the effect of their guidance system. More advanced guidance was under development. Television was a promising technology for guidance, but the early television cameras were horribly expensive and not reliable enough for the rigors of combat flights. Radar guidance was also developed and was used on a small scale toward the end of the war on the US Navy's Bat anti-ship glide bomb. Even more curious guidance methods were considered. The eminent behavioral psychologist B.F. Skinner suggested a novel alternative for bomb guidance. A pigeon would be conditioned to peck at the image of a ship on a small television screen. A camera mounted in the nose of the bomb provided the image to the pigeon guidance compartment. By pecking on the quadrant of the screen where the ship was located, signals were electrically sent to the bomb's control surfaces, steering the bomb towards the target. Pigeon guidance was not perfected before the war ended, but as crazy as it sounds, pigeon guidance contained the critical ingredients of modern missile guidance. In later years, computers would replace pigeons. In the summer of 1944, with German B-1 buzz bombs raining down on London, the most desperate guided bomb project of the war was attempted under the code name Aphrodite. Allied intelligence discovered 4 huge bunkers on the French coast, being prepared to launch the deadly new B-2 missiles on London. The bunkers were impervious to conventional bombs. Something far more devastating was needed. Worn-out bombers were packed with tons of high explosives and fitted with radio control guidance. Now volunteer pilot flew the aircraft to cruising altitude, then bailed out. The bomber was then guided to its target by radio control from a chase plane. The project worked better in tests than in real combat conditions. Bunkers were eventually captured by the Army. The swan song of the American guided bomb effort came after the end of World War II. The most powerful guided weapon developed, the 6-ton Tarzan bomb, was not fully ready until the end of the war. It used radio command guidance like the German Fritz Hex. Tarzan's first saw action during the Korean War in 1950. Carried by B-29 bombers, the Tarzan bombs were very successful in attacking small, vital targets such as bridges. In World War II, Japan was not the world-class technological power it is today, so another approach to accuracy was developed. In place of pigeons or radio control, the Japanese used a far more reliable guidance system: human beings. Japanese pilots were brought up to accept self-sacrifice as part of the creed of the samurai. Their kamikaze planes were jammed with high explosives and blown into American warships. The most deadly were special rocket-propelled kamikazes called Oka, or cherry blossom. The Oka was in many ways a forerunner of the modern anti-ship missiles. Kamikazes took a deadly toll, sinking and damaging hundreds of ships. Interest in guided bombs waned in the 1950s. The devastating power of the new atomic bombs convinced many that accuracy was of far less importance. But when the US became involved in the Vietnam conflict, the need for precision-guided bombs became evident once again. At the time, the only guided weapon in service was the Bullpup missile. Bullpup worked much like the German or American guided weapons of World War II, with a radio command system. But it was very difficult for pilots to control these while flying high-speed jets. Another guidance technology was needed. The Vietnam War saw a revolution in precision accuracy made possible by a host of new technologies.
In Vietnam, for the first time, you see laser-guided bombs. Now, in the past, when bombing is done, it's like shooting a gun. You make some hits, you make a lot of misses. If the target is small, say a bridge, a power station, something like that, then the number of airplanes that are needed to get a reasonable chance of hitting it can be enormous. Every one of those airplanes has a very fair chance of being shot down. If somehow you could guide a bomb right to that little point, then only one airplane might be needed. That airplane would have the same chance of being shot down, let's say, as any one of the hundreds that are needed otherwise. The laser was a way of doing that, because a laser is a line. You can point it at the target, the bomb looks for the reflection of that radiation, goes right there. Now, they sometimes miss. It isn't as simple as one bomber instead of 100. But just the fact that these small targets could be hit reliably, and by the way, hit from a much greater distance, made a tremendous difference to the airplanes. It made them much more effective. It cut the cost of hitting these things enormously.
Vietnam first showed the effectiveness of laser-guided bombs. Take, for example, the vital Van Hoa Bridge. For 3 years, U.S. aircraft attacked it unsuccessfully, dropping 1,250 tons of bombs and losing 8 aircraft in the process. In May 1972, the bridge was finally destroyed in a single mission by F-4 Phantoms equipped with laser-guided bombs. Further development of laser-guided bombs continued after the Vietnam War. The seeker in the nose of the bomb is pre-programmed to hone in on reflected laser energy. But the most sophisticated portion of the laser guidance system is not the bomb itself, but the laser designator carried under the aircraft. This system must be precise enough to aim the narrow laser beam to within a few feet of the target. The bomb hones in on the laser energy reflected from the target. The bomb seeker sees only the reflected laser energy. Nothing else. The F-111F strike aircraft carried is one of the most sophisticated of these laser designation systems, the PaveTac pod. The pod is kept in a retracted position for most of the flight to protect its delicate electronics. When near the target, the pod is rotated so that its sensors are exposed. The PaveTac pod was first demonstrated in combat during the 1986 raid on Libya. As seen in this footage of a strike on the Libyan airfield, the PaveTac pod enables the crew to strike the target with considerable precision. The success of the American laser-guided weapons led other countries to develop their own examples, such as France's BGL-guided bomb. During Desert Storm, the French Air Force also deployed the AS-30L laser-guided missile. The difference between a guided bomb and a guided missile is that the missile is powered by a rocket engine, while the bomb is not. The AS-30L proved its accuracy in the Gulf War on missions like this. Operation Desert Storm saw the most extensive use of laser-guided bombs in history. American, French, and British strike aircraft used them in large numbers. They were the weapon of choice when missions called for attacks on small, pinpoint targets, such as bridges, aircraft shelters, and command bunkers.
Don't stop.
And who just got
40.
Hold on.
One was a bit short. Flash. Good job.
The advent of more advanced bombs and more sophisticated laser designators gave them a very high success rate, over 80%. Lasers are an effective way to guide a bomb, but if the target is heavily defended, laser guidance does have its limitations.
To make that work, the airplane has to stay around while the bomb is in motion. That does make it somewhat more vulnerable. The alternative, which shows up during the Vietnam War, and you still see now, is called electro-optics, EO-guided bomb. It's a television bomb. And what happens is that the operator in the airplane has a television screen. He sees through the bomb when the bomb is hanging on the airplane. He can say to the bomb, go to that, and in theory the bomb then fastens on some particular feature, goes to it.
There are two types of electro-optical weapons. One type, called fire and forget, works much like the pigeon bomb of World War II, but a simple computer replaces the pigeon to guide the bomb or missile. The crew locks on the target using the television camera in the head of the weapon, and the computer keeps the weapon aimed precisely at the target after release. The second alternative is to allow the crew to steer the missile all the way to the target using the TV image from the missile scanner.
Well, if we take a modern electro-optically guided weapon, this would be like the EOGB that is carried by the F-111 aircraft, and this has a TV camera in the nose, pretty much, and pretty much like the TV camera that we're using today. And so the operator in the aircraft, he is able to see what the missile nose is pointed at. And from there on, the missile is guided to the target using a little joystick controller, pretty much like those early German weapons. But of course, and we've all seen the television footage of this, as the missile gets closer and closer to the target, you see the target in greater and greater and greater and greater detail. So these weapons are very, very precise indeed nowadays. And of course, being more modern, these are third, fourth, fifth generation weapons, they're very much more accurate and reliable than the early ones were.
One of the most revolutionary changes in electro-optically guided weapons is the imaging infrared seeker. Earlier weapons were useful only in daylight. New generation of weapons, such as the Navy's SLAM, can also see at night. The television sensor in the nose of the missile can detect the slight heat differences between the target and the natural background, giving the pilot a detailed image of the target. The pilot can then steer the weapon all the way to the target. The main advantage of these weapons is that they can be launched long distances from the target, so that the attacking aircraft does not have to run the gauntlet of enemy air defenses. Imaging infrared seekers can also be used on shorter-ranged fire and forget weapons, such as the Maverick missile. The pilot locks on the seeker, and the missile guides itself to the target without any further need for corrections. These weapons can be used day or night to attack small, moving targets.
The important thing about an infrared system is it is able to see through the dark. It can't see through cloud, but it can see in the dark, and so having that system, it confers the ability to operate at night. Now, that may not sound much, but in fact, in recent years, over the past couple of decades, the US forces have moved much more to the night attack mode, when if you've got good night systems, you can operate, and if your enemy hasn't got good night systems, he can't operate. And here again, we saw that in the Gulf War, when the most important operations were carried out at night and they were achieved with minimal losses. Infrared made that possible.
We may soon see the first true smart weapons, able to distinguish specific types of targets without any human guidance.
As time goes on, electronics gets cheaper, the bombs get smarter, you begin to try to make bombs which can recognize images themselves. That's a current idea. If they can do that, they can be sent in the general direction. The airplane doesn't have to be anywhere near the target. He leaves, the bomb says, yes, that's what I wanted, and that's been everyone's dream.
By increasing accuracy, a single warplane can carry out the missions of many. The quest for pinpoint precision will continue. New technologies have had as revolutionary an impact on air power as the guided bomb.
FirePower, the world's largest and most complete video cassette series on contemporary military technology. There are many more titles in this series which you can order now. If you want the latest in today's advanced weapon systems in the air, on land, and at sea, look no further. For program titles and information on how to order, call us at 1-800-377-7773 and get FirePower.